Hi students, in this class we solve problems based on time reversal and the linearity property of Z transform. Okay, let us see the first problem. What is that? Here they have given x of n is equal to 2u of n plus 3a of n, a power n, u of n. Right? So here two signals are weighted by the factor 2 and 3. So, what is the linearity property? If you have two signals, you find the transform of individual signal and add it. So, first I find the transform of 2u of n. The transform of 2u of n, 2 is constant. Then I know the transform of u of n is z by z minus 1. Right? So, this is the transform of 2u of n, 2 into. Similarly, what is the transform of 3 u of n? Right? So 3 is a constant, I take it outside. The transform of a and u of n is z by z minus e. So what is the total z transform? Sum of individual z transform. So it is 2 into z by z minus 1 plus 3 into z by z minus a. Simple. Okay, that. What about second problem? 2 del, 3 del n, 4 del n plus 1. So x of n is 2 del n minus 1 plus 3 del n plus 4 del n plus 1. Right? So again I use linearity property, find the Z transform of individual signal and add it. So 2 is a constant, take it outside, Z transform of del of n minus 1. 3 is a constant, Z transform of del of n plus 4 the transform of del of n plus 1. Okay, fine. So how can we do 2 the transform of del of n minus 1? We know the transform of del of n is 1, right? What is the transform of del of n minus 1? So I write the summation n goes to minus infinity plus infinity del of n minus 1 z power minus n. Here you see del of n minus 1 exists only at n is equal to 1. At that point the value of del of n minus 1 is 0, otherwise it is 0 else. So this exists at only n is equal to 1. When n is equal to 1, del of n minus 1 is 1. So this is 1, when n is equal to 1 it will be z power minus 1. So z transform is 2 into z power minus 1. Here so what is the transform del of n? 1. So 3 into 1. Then 4 into z of n plus 1. Del of n plus 1 means you put del n plus 1. So this will exist only at n is equal to minus 1. When n is equal to minus 1, del of n plus 1 is 1. So if we substitute n is equal to minus 1 here, it will become z of plus 1. So it will be z. So the answer is 2z inverse plus 3 plus 4z. Clear? Simple. Fine. Okay. So similarly, if you want to know what is the transform of del of n minus k, this is summation. The transform of del of n minus k, n goes to minus infinity plus infinity. Del of n minus k z power minus n. You see this exists only at n is equal to k. Yes or no? So when n is equal to k, it will become del of 0. Del of 0 is 1. All other values it is 0. So when n is equal to 0, k, it will become 1. So z power minus k, because n is equal to k. So z transform of del of n minus k is z power minus k. Right? N plus k is you see it will become z power plus k, it will come. So that is the answer. So that's why we got answer like this. Fine. What about third problem? Third problem is u of minus n. Fine. So it is simple problem. X of n is equal to u of minus n. I know for the transform of u of n, I know z by z minus 1. I want to find the transform of u of minus n. So it is x of n, it is x of minus n. So if the transform of x of minus n is nothing but z must be replaced by z inverse. That's what we have studied. So you replace z by z inverse. So if you simplify it, what you get is 1 by z divided by 1 by z minus 1. It will be 1 by 1 minus z. Clear? So this is the way we have to solve the problem. Clear or not? Now we have to see ROC, how to find ROC for all the problem. For this problem, ROC is, right, this Z inverse must be less than 1. Clear or not? So, okay, so what is the thing? Z inverse must be, right, greater than 1. Yes, sorry, not less than 1, it must be greater than 1 because this R must be greater than 1 because this is the ROC for U of n. So similarly here Z inverse must be greater than 1. So 1 by Z must be greater than 1. This must be mod Z must be less than 1. If you bring a mod Z here, mod Z must be less than 1. Clear or not? So if this is the Z transform with the ROC Z mod Z greater than 1. U of minus n means we have to replace Z by Z inverse, time reversal property. Use time reversal property. What time reversal property? X of minus n as Z transform of X of Z inverse. So Z must be replaced by Z inverse. So I got this. So here Z must be replaced by Z inverse. So ROC must be less than 1. Okay. Fine. So what about this problem? For this problem, ROC is, again you see, this problem has ROC of everywhere. When Z is equal to 0, it is nothing but 2 by Z. When Z is equal to 0, the function becomes infinity. So ROC is everywhere. Okay. ROC is everywhere in Z plane except Z0. When you substitute Z0, the function becomes infinity. Similarly, if you substitute Z is equal to infinity, due to this, the function becomes infinity. So ROC is everywhere except Z is equal to 0 and infinity in Z. Clear or not? Simple problem. I hope you understand all the problems. If you have any doubt, please ask me in comment section. Thank you.